The Soviet Union was a vast country, and ordinary trucks were far from suitable for all of its regions. The far north, western Siberia, and the deserts of Central Asia required vehicles capable of operating where roads barely existed. That is why engineers developed machines with tracks, articulated frames, wide tires, and unusual drivetrains. Some entered series production, while others remained prototypes. In this video, we look at 5 of the most unusual Soviet all-terrain vehicles. Let's begin. Opening our list is the Gaz-47, a tracked snow and swamp transporter developed at the Gorky automobile plant in the early 1950s. The project was led by Sergei Mikhailov, and in early 1952, 3 prototypes were sent for testing. The engine and transmission were mounted at the front of the hull, with a 2-seat cab behind them and a cargo platform at the rear. The running gear drew on experience from producing the light T-60 and T-70 tanks. Each side had 5 rubber-tired road wheels and a wide track. The rear road wheels also served as idlers and were used to tension the tracks. Ground clearance was about 40 centimeters, while average ground pressure was roughly 0.2 of a kilogram per square centimeter. Power came from an inline 6-cylinder gasoline engine from the Gaz-51 family, producing about 70 horsepower. The transporter could carry up to 1 ton of cargo and reach roughly 35 kilometers per hour. Its all-metal welded hull allowed it to cross water obstacles by swimming. There was no separate water jet propulsion system. Thrust in the water came from the tracks themselves. The main test program began in the spring of 1952. The winter stage of state trials followed the route Vorkuta, Ust-Kara, Amderma. The vehicles crossed tundra, snow, and the ice of the Kara Sea while also towing artillery systems. Testing then moved to the Arkhangelsk region, where the machines operated on waterlogged ground and in swampy terrain. After the program was completed, the design was refined, and the plant was ordered to build a pilot batch of 10 vehicles. Series production began in the mid-1950s. The transporters were supplied to the military, geologists, and construction organizations, and soon reached Antarctica as well. 4 of these vehicles took part in the first Soviet Antarctic expedition. They operated near Mirny Station, maintained links with remote points along the coast, carried cargo, and helped scout routes for the first inland expeditions. In the north, the all-terrain vehicles were used for geological exploration and to supply remote field teams. It was among geologists that the machine acquired the nickname Stepanida. Production continued until 1967, when this model was replaced by the more advanced Gaz-71. Its successor received a more powerful engine, achieved a higher speed, and continued the same line of compact track transporters. 4th place goes to the Nami 0127, an experimental pipe carrier with an articulated frame developed in the mid-1960s for gas pipeline construction in Central Asia. Production pipe string carriers based on heavy trucks performed poorly in sand. So the Nami Institute proposed a 4-axle all-wheel drive tractor that steered not with its wheels, but by articulating the frame. The project appeared in 1965, and 3 years later, the Moscow Experimental Mechanical Plant built 2 prototypes. The vehicle consisted of 2 sections connected by a central joint. When turning, hydraulic cylinders pivoted them relative to each other, while all 8 wheels remained fixed relative to their axles. The minimum turning radius was just over 10 meters. The running gear used 2 walking beam bogies, while the cab came from the ZIL 130. Under the hood was a Yams 238 V8 diesel, producing about 240 horsepower. The 2 prototypes differed in their wheels. One had huge pneumatic rollers, while the other used arched tires. They were first tested as standalone trucks, then converted into pipe string carriers with 2-axle bolster trailers. The complete road train had 12 wheels, 8 of them driven. Payload capacity was 12 tons for the pneumatic roller version and 16 tons for the arched tire version. In 1970, both vehicles were sent to the Central Asia Center gas pipeline project in Uzbekistan and Turkmenistan. Tests took place near the Gazli field and in the sands of the Kizilkum Desert. The road trains carried 36-meter pipe strings weighing 13 tons. The pneumatic roller version proved the most successful. On a comparative route, it traveled 31% faster than a pipe carrier based on the Kraz 255B. The difference was also clear in fuel consumption. Over 100 kilometers, the experimental road train used an average of 163 liters, while the Kraz used about 291. On steep dunes, the tractor climbed slopes that production vehicles could manage only with tractor assistance or by taking a detour. Without the trailer, the machine climbed a natural slope of 16 degrees. After the trials, the gas industry proposed putting the vehicle into production, but the automotive ministry did not support the initiative. The pipe carrier never entered series production, and both prototypes were converted back into flatbed trucks. However, the concept itself did not disappear. In the mid-1970s, it was used to develop the new articulated Kraz 6434 tractor. Third place goes to the ATS-59G, a medium-tracked artillery tractor developed in Kurgan as an evolution of the previous model. Its main problem was the cramped two-seat cab. The driver and commander sat at the front, while the rest of the gun crew had to ride on the cargo platform. The improved version was designed under Gerasim Avdiev, and by the end of 1966, the technical documentation was almost complete. The most noticeable change was a new all-metal six-seat cab. It was moved forward and positioned partly above the engine and transmission. It could now accommodate almost the entire gun crew, along with some of the equipment. The cab was sealed, fitted with a filtration and ventilation system, and given more powerful heating. Engine cooling and lighting were also improved, and an engine preheater was added. The powertrain remained almost unchanged. The tractor used an A650G 12-cylinder diesel, producing 300 horsepower, developed from the V2 engine family. Curb weight was about 13.8 tons, and the platform could carry up to 3 tons of cargo. Most importantly, the vehicle could tow trailers weighing up to 14 tons. On the highway, the machine could reach about 39 kilometers per hour without a trailer. Its range with cargo and a towed system reached 500 kilometers. A recovery winch was mounted at the rear, and bulldozer equipment could be fitted to the chassis when needed. Alongside the standard version, there were variants without the winch and with a small lifting boom. Series production was initially planned for the Kurgan machine building plant, which already produced its predecessor. But the plant was being converted to produce the BMP-1, leaving no spare capacity for the new tractor. Production was licensed to Poland instead. Assembly there began in 1969 and continued for almost 2 decades. The vehicle was officially accepted into service with the Soviet Army on February 28, 1970. In military service, the tractors worked with heavy-towed artillery, including 130mm M46 guns and 152mm M47 guns. But from the mid-1970s, some vehicles began to be transferred in large numbers to the civilian economy. The tracked chassis, high tractive effort, and ability to handle heavy trailers proved useful far beyond the military. Series production in Poland ended only in 1988. Second place goes to the BT-361A01 Tumen, a heavy 4-track swamp transporter developed in the late 1970s for oil and gas construction in Siberia and the Arctic regions. The order for the new machine appeared in 1978. It was required to carry oversized loads weighing up to 35 to 36 tons across terrain where even dirt roads were absent. Development was assigned to the Tumen Special Design Bureau Gastromachina, with Oleg Vasiliev serving as chief designer. The project took only about 6 months to prepare. A conventional layout was unsuitable for this payload, so the machine was mounted on 2 separate tracked bogies. Above them was a common cargo platform, supported by both sections through pivot assemblies. The front bogie carried the engine and cab, while the rear used a similar running gear layout. Hydraulic cylinders changed the relative position of the sections to steer the vehicle. As a result, the 15-meter transporter had a turning radius of about 17 meters. Some components were borrowed from the Kirovets tractor. Under the hood was a Yams 240 BM 12-cylinder diesel, producing 300 horsepower. It was paired with a 16-speed manual gearbox, featuring hydraulically controlled shifting without interrupting power flow. Torque was transmitted to both bogies through a system of shafts. Each bogie had 2 track assemblies with wide rubber metal belts about 1 meter 20 centimeters across. Curb weight was about 46 tons, while the 8-meter platform could carry up to 36 tons. A winch was installed at the front with a 70-meter cable and a pulling force of almost 20 tons. Maximum speed reached 15 kilometers per hour, and ground clearance was 600 millimeters. Without preparation, the machine could ford water up to 1.5 meters deep. The platform was used for more than ordinary cargo. Production chassis also carried tanks, containers, and special equipment. The first prototype was tested in the late 1970s, after which the swamp transporter was recommended for series production. Manufacturing began at the Kropotkin Experimental Machine Building Plant. By the early 1980s, these machines were already working on oil and gas construction projects, carrying equipment and heavy loads across northern regions. At least several hundred examples were built in different versions. By the end of the 1980s, the main orders had ended and production was discontinued. The next development of the concept was the much larger 4-track Yamal transporter. First place goes to the SVG 701 Yamal, one of the highest capacity tracked all-terrain vehicles created in the Soviet Union. The project appeared in the mid-1980s, when the 36-ton payload capacity of the Tumen was no longer sufficient for some oil and gas equipment. The new machine was developed by specialists from the Gastroymaschine Special Design Bureau, together with the Canadian company Foremost, which had extensive experience building articulated all-terrain vehicles. The general layout was based on the Canadian Husky 8, but the Soviet machine was considerably larger. The all-terrain vehicle consisted of a 20-meter platform mounted on 2 independent tracked bogies. Each could pivot relative to the body using hydraulic actuators and also oscillate in the longitudinal plane to follow the terrain. As a result, despite its enormous size, the machine had a turning radius of about 22 meters. Each bogie had 4 road wheels with pneumatic tires, which replaced a conventional suspension. Particularly impressive were the tracks, measuring 1 meter 85 centimeters wide. Thanks to the large contact area, ground pressure even at full load was about 0.38 kilograms per square centimeter. Ground clearance reached 520 millimeters, while the permitted fording depth was 2.6 meters. Behind the 3-seat cab was an 8-cylinder Detroit diesel engine producing 715 horsepower. Fuel capacity exceeded 2,100 liters, enough for roughly 700 kilometers. A separate diesel generator powered the equipment when the main engine was shut down. The cab itself had good thermal insulation and no fewer than 3 heating systems, since the machine was intended to work in Siberia and the Arctic regions. Its main advantage was the cargo platform, 12.5 meters long and about 4.5 meters wide. It could carry up to 70 tons. The all-terrain vehicle itself had a curb weight of about 27.5 tons, while gross weight approached 98 tons. Maximum speed did not exceed 15 kilometers per hour. For loading operations and recovering stuck vehicles, it was equipped with a winch providing about 45 tons of pulling force. The first 2 prototypes were built in the mid-1980s. They were tested not only at proving grounds, but also directly on northern construction sites. The machines carried oversized equipment, transported other vehicles, and were used as tractors. At the same time, an entire family of specialized versions was considered, including an excavator, a fire engine, and a heavy crane. The project never reached series production. Around the turn of the 1980s and 1990s, it ran into financial problems, while international cooperation became sharply more difficult. As a result, only 2 confirmed examples were built. They continued to be used on real jobs for some time, but no further machines appeared.